Okay, we are going to start on section 4.3 on log functions. Now, log functions technically are inverse of exponential functions. These functions are essential for finance applications and its use would be evident very soon. The definition of a log function is as follows. So y is log of x to base a, and that means that a raised to the power y is equal to x. So when somebody says y is log of x and the base is a, what they mean is that a raised to the power y is equal to x. So these two statements are equivalent to each other. When this information is written in this manner, then it's called the log version. And when the same thing is written as follows in this manner, it's called the exponential form. Both have the same information, it's just written differently in these two manners. So first thing is how you read it. So you read it as log of x to the base a. So suppose somebody writes the following. So this is read as log of 100 to base 10. Now what does it mean? So let's learn how to interpret it. The best way to do it is to remember this phrase. So log of x to base a is the power that a must be raised to produce x. So if we go back to this and look at this, what does this really mean? What is this equal to? So it is the power that 10 is a. So 10 must be raised to give you 100. So we know that the power would be 2. So this is equal to 2 because 10 raised to the power 2 is 100. So let's read some more of it. So y is log of 8 to base 2. So what is the value of y? So what is this y? Well, this is the power that 2 must be raised to produce 8. So 2 raised to what is going to give us 8? It must be 3. So therefore log of 8 to base 2 is 3. Similarly, what is log of 81 to the base 3? That means 3 raised to what is going to give me 81. So if you think about it, 3 times 3 times 3 times 3 gives me 81. So that means it's 3 raised to the power 4. So 4 is what we are looking for. So that means log of 81 to base 3 is actually 4. Now, choosing different values of this base, suppose a could be 10 or a could be that special number e, we get two special cases. So let's look at the definitions. So when somebody says y is log of x, then what they mean is 10 raised to the power y is equal to x. In other words, y equals log of x is same as saying log of x to base 10. So when we say log of, suppose, log of 8, that means log of 8 to base 10. So whenever you don't see anything here, the base is 10. Similarly, suppose a is this special number e, Then we got what are called natural logs. So if you see y equals ln x, now this is pronounced as ln. So y is ln x means log of x to the base e. So suppose somebody says ln of 8. Now what they really want to say is log of 8 to base e. So this is just a simple note, a simpler notation. Okay, so we have seen the definition of logs, and we have seen these two special cases. Now let's try and do some examples so that we get comfortable with it. So the first one is we have to find y, which is log of 10. So we know, log of 100. So we know that log of 100 to base 10, when you don't see anything, that means the base is 10. So now we have to find it by definition. That means we have to figure out 10 raised to what is going to give me 100. Now obviously we know that this number must be 2 because 10 squared is 100. Therefore, this y, which is log of 100, must be equal to 2. And then you can do it also by using a calculator. So all of you should take out your calculators and find the log key in it. You would see the log key, it's clearly visible, and you can find it. And if you punch log of 10, log of 100, then you will see that the answer is 2. Now let's go to the next example. Y is equal to ln 5. Now remember, ln 5 means log of 5 and the base is e. So first, by definition, now that is impossible because what we are supposed to do is sort of guess e raised to what is going to give me 5. There's no way I can guess that. So no way anyone can guess. So we have to use the calculator. So if you take out your calculator again, you will find the ln key right next to the log key. And so punch in ln of 5 and it should give you this sort of number. Now remember, these are irrational numbers, so they continue forever, but we are only interested in the first 4 decimal places. Let's practice some more. Now we want to find log of 16 and the base is 2. So that means I am interested in guessing 2 raised to what power will give me 16. So if you think about it, it must be 2 raised to the power 4, which gives me 16. Therefore, log of 16 to base 2 must be 4. Now log of 3 to base 27. So that means I want to know 27 raised to what power is going to give me 3. Now this is not very obvious, but 27, if we take the cube root of it, that means raise it to the power 1/3, then I'm going to get 3. So therefore, log of 3 to base 27 is 1/3. But by now you must be noticing that guessing is not going to do too much for us. For example, we could come across log of 5 to the base 2, but this is impossible to guess because what power should 2 be raised to get 5? Nobody can guess that. So there must be some better way of doing it. So we come across what is called the change of base theorem. This is a very handy theorem. It says that for any positive numbers a and x, log of x to base a can be found as log of x divided by log of a. So look at this example. Suppose I want to find log of 5 to the base 2. So notice that x is 5. So I'll do ln of 5 and then divided by ln of 2. And then one can use the calculator. You can find ln of 5 divided by ln of 2, and that will give me 2.3217. So similarly, suppose we had to find log of 16 to the base 2. Now suppose you don't want to go through guessing the answer. All that you have to do is use your calculator, find ln of 16 divided by ln of 2. So go ahead and do it, and within a few seconds you would notice it comes out to be perfectly as 4. So let's practice a few more of these examples of how to use the calculator and also not make mistakes while using the calculator. So first we have to find 4 times log of 10. Now you have to have your calculators out to be able to do it. So you would find log of 10, and when you do that you will see that this is equal to 1, and then you are multiplying by 4. So when you multiply by 4 after that, you will get 4. Now similarly, we want to find this quantity. So first we would find log of 1/4, and the base is 2. So if you do that, you're going to get -2, and then you would multiply it by 4, and that will give you -8. Now these 3 examples are to show you how you have to be careful and not mix up these 3 very similar looking things, but they are totally different in their meaning. So this is log of 75 to base 3. So you would find log of 75 to base 3 by using the change of base theorem, and that would be ln of 75 divided by ln of 3, and you would get this answer. On the other hand, log of 75 divided by 3 is a totally different thing, and you have to enter it in your calculator properly, and you should get this answer. And finally, log of 75 over 3. Now this you have to enter in your calculator properly. First you should press the log key and then the parenthesis key, then 75 to be negative.